Hello everyone. Welcome to ProtaStructure presentation for today. I am Yasemin Aktaş. I am a civil engineer and I am working as a technical support engineer for Prota software for a long time. Today with my colleague Sarp Çavuşlar and me, we'll talk about how we can model the steel structure in ProtaStructure 2022. Here is our agenda for today. I will quickly talk about the journey of Prota and what we offer and the core advantage of our software technologies. I will then hand over to Mr. Sarp for the demonstration of our solutions. Here on this map, you can see our offices and partners around the world. Today, we operate with more than 14 offices located in Poland, Peru, Turkey, Malaysia, Singapore, and Philippines. As a structural engineer, we wear multiple hats. We need to do building information modeling, and then we need to do analysis and perform design of our steel structure and steel structures, create detailed drawings, and we even create fabrication and constructible information. We also coordinate and share project information with other stakeholders and software through building information modeling. Our core advantage is that ProtaStructure suite offers these necessary features in a single suite. A software for streamlined modeling and analysis, a software for designing for your steel connections, concrete beams, core walls, foundation, and more. A CAD software for dedicated structural drawing and producing all your engineering drawings with component design of other project elements like retaining walls. A fabrication software for producing all your construction and shop details. Here you'll see our latest technology solutions offered in a single suite for the structural engineering market. ProtaStructure for modeling, analysis, and design of your structures. ProtaDetails for your automated detail drawings. It includes intelligent rebars and design libraries such as retaining wall, scaffold design, and detailing. ProtaSteel for your steel detailing and automated connection design for your structure. There are drawings and calculation reports within this technology. ProtaBeam to bidirectional link your model with other building information modeling platforms and software solutions like Autodesk Revit, Allplan, and Archicad. To summarize that, you can find the modeling, analysis, design, detailing, fabrication, and building information modeling BIM technology in a single package with ProtaStructure. Today, with this webinar, we target to explain to you advanced techniques of steel member modelings and curved beams, steel domes, load editor, truss system, and exporting to ProtaSteel and section design of the steel members and calculation reports, and more. Now we can proceed to model the steel structure with ProtaStructure. Thank you for all listening and attention. Mr. Sarp, you can share now your screen.
Thank you for your informative presentation, Ms. Yasemin. Now let's pass to modeling part of our webinar. Hello, my name is Sarp Çavuşlar and I am working as a technical support engineer in Prota software. Today, I will tell you about modeling of steel structures and analysis in ProtaStructure 2022 version. First, I will model and analyze hanger structure. After that, I will create a steel dome. Let's define some axes in here. I used orthogonal axis generator to define axis. Let's assign some axis in Y direction and some axis in X direction. Now let's insert some stories. I insert 3 stories for this model. In addition, you can add intermediate stories between stories. Also, you can arrange the story height. Let's edit the story and change the structural system as steel. Because our structure is a steel structure, that's why we should change the structural system. for true calculations. Now let's continue with the 3D physical model. And now let's look at the materials in the Building Setout tab. The default materials in ProtaStructure as shown. For example, steel column material is S275, and also you can change the steel grades as well. Now I want to assign steel columns to these axes. In the steel column property window, you can change the name of the label, defining stories, which is LAN, or the ankle, and you can change the section of steel members. As you see, ProtaStructure has a variety of steel sections in its steel database. Also, you can find the steel section that I've been using in Japan, Thailand, and Singapore. Also, you can choose the built-up steel as well. And now let's change the section angle to 90 degrees and click OK. And I will change the length part of our column to 3 because our structure has a 3-story. Now I assign steel columns to axes. You can assign steel columns with different ways, such as dragging or driving a line. And let's define the steel columns to another axis by dragging methods. Okay, it's finished. Now let's define a steel beams to our model. I want to begin with the 3rd story of our model to creating steel beams. You can change the label, section angle, curved beam properties, and you can set end releases manually in the steel beam ribbon tab. Also, you can change the del Z values of steel beams for giving elevation. Now I'm inserting the steel beams by using drawing a line property and click yes for splitting beams between columns. And also let's define steel beams to another axis. Okay, it's completed. Now I want to talk about with the filter option. In the selection filter property, I only want to choose beams. Let's pick the beam box. And now I want to generate the steel beams to the 2nd and the 1st story of our structure. I select the 2nd and 1st story, and as you see, our beams were generated. Okay, our beam insertion is finished right now. Let's continue with the inserting steel trusses to our model. You can insert steel trusses between columns. Let's assign a steel truss between these columns. You can change the steel truss types and steel truss patterns. I select this one and change the truss support placement as top chord. And I will change the apex height as 150 centimeters. And I change left heel height and right heel height as 70 centimeters. And number of spans as 4. Secondly, you can change the sections of members of steel trusses and arrange their hinges. Also, you can add splices to members, or you can import truss drawings with DXF format to ProtaStructure. Or if you have created a steel truss before, you can upload it from the truss library. Let's click the user-defined truss. In this part, you can delete the members of steel trusses, and also you can add vertical, diagonal, and horizontal members to trusses, and you can do it much more. Let's click OK. And now our steel truss was created. Now let's duplicate the steel trusses to backwards of our structure fastly. Okay, let's continue with the braces. You can add braces between columns, beams, and trusses. I will insert the braces between columns now. And I want to change the count to 3 because our building story number is 3. You can change only one brace, or you can select with control button to hold braces between these columns. Also, you can change the braces profiles or brace types. Let's change the brace profile as pipe section. And also you can change the geometrical properties of braces depends to your model. Then let's change the brace type, X brace, diagonal brace, we can use it. Let's change the X brace. Also you can set offsets. Let's change the Y offsets to 15. In this case, if we examine the layout in the preview window, we will see a gray line. This line represents the analytical model. We may not need to apply the change to the analytical model. Since offsets as short as 15 cm, it will not affect the analytical model too much. However, when we make the offset value as 50 cm, we can see the distance between the analytical model and the real model more clearly. Similarly, if the offset value is large enough to affect the analytical model, we need to tick the boxes which is applied to analysis below. Now let's change the another offset in F2 points. As you see, three of them must change. Now let's assign another braces to the end of our structure, the other side of our structure. Let's assign it here. Now I want to talk about the frame members. You can change the label type such as general, vertical brace, horizontal brace, purlin, and girts. I select the vertical brace. You can change the section. Let's select the pipe profile, which is tubo D. Let's click select and OK. You can arrange the entrylists and analytical offsets. Let's write a minus 50 cm in Z value. And let's make a change in analytical offsets. I should change the Z value. Update. Okay, it's true now. Now let's make the thing in the second story. Okay, now let's do it in the first story. As I mentioned before, you can define braces between trusses, and I want to count 2 in top chords. I want to count as 2 in the upper side of steel truss, and I don't want any braces on the lower part of the truss. Let's delete the offset values and click OK. As you see, our braces were created. Let's assign the braces on the other side of the structure. I made the same thing in the brace property menu. Okay, now it's finished. Now let's define the purlins to our steel structure model. Purlins can be added between steel trusses or steel beams. You can change the profile of the purlin, and you can also change the generation method of purlin as by truss joints or by spacing. And I select generation method as by spacing. And as you see, the upper parts of purlins has empty space. You can click the fill from the top option to fill these spaces. Now I want to model wind columns to the front side of this structure. Let's click here and here. As you see, our wind columns were created on the front side of our structure. And I want to extend these columns to the steel trusses by choosing the columns and click extend to column to member button. As you see, both of them are extended to the trusses. Let's change the section of these columns. I want to use IPE 220 profile and change the section angle to 90 degrees and click OK. Now let's define wind columns to another side of steel structure. I use mirror property. First, I choose the both of the wind columns and click mirror. After that, I select the middle axis of our model. As you see, our wind columns were mirrored. Now let's define beams between these wind columns. Let's define it here, here, and here. Now let's pass to second story. I want to assign beams between these wind columns as well. Between here, here, and here. Now let's change the section of all beams by using filter option as I mentioned before. I want to use IPE 178 profile. In here, let's select beams, click edit section material, and change the profile. Let's click OK. As you see, all of them were changed. Now let's control these beams about hinges. Let's control of the hinges of our beams. Okay, it's true right now. Let's close it. Also, let's assign the steel beams to another side of our steel structure. Let's assign in the second story. Let's pass to first story and insert some steel beams here between these wind columns. Now let's assign some of the girts to our structure. Girts can be placed between column members. You can change the profile of girts. You can change the section alignment as under the section or on the section. Or also you can set the geometrical properties of girts. I will also assign here another girt. In the middle of our structure I will create a girt, but I will change the bottom member's offset. The reason why I do this is I want to create a space like gates, and I changed the HO value as 320, and also I will insert another girt to another side of our structure. Also I will assign a girt in the front of the structure. Okay, now it's finished. Now I want to talk about the support types. For this, I will insert a cantilever steel beam and cantilever frame member to our structure. First, I have to offset the axis, and after that, I have to stretch the axis. Let's offset this axis about minus 250 centimeters and stretch the horizontal axis. Let's stretch it to horizontal axis. And I am inserting the cantilever steel beams in here. And after that, I will insert cantilever frame member in here. In the frame member property, you can change the section. Okay. Let's arrange the offsets. The Z value has 0. You can also set the entry-indices manually and change the section. Let's change the section to IP 180 and click update. Now let's define some support types in here. The default support type is fixed support. I am inserting a pin support to here. For this, I have to choose these ones. And click OK. And now, right click to the frame members and open the properties and change the support type as pin support. And I will do the same thing to the beam members. Let's insert a pin support to here. And now I want to create a steel columns in the first floor. After that, I will model arc frame members to these columns from third story to first story. Let's change the del Z value and assign pin supports also to this steel column. And I want to extend 20 centimeter elevation to our steel columns. For this, I should give the 20 to the del Z value. And let's define another steel columns to these axes by driving a line method. Let's change the angle to 90 degree and click update. As you see, our column was extended 20 centimeter up. Now let's define another steel columns. Okay. Now let's move the axis. As you see, let's click move and click F2 button and write 100 centimeters. As you see, when you move the axis, the members that are on the axis are moved as well. Now let's assign arc frame members between third story and first story columns. I will select the type of frame members as general, and I will click curved box in the insertion methods and change the plane normal angle as 90 degree and apex distance as 130 centimeters. And let's delete this support. Let's delete this support to as none. And now I'm assigning the other frame members between these columns, between these from the third story and the first story. last one. Okay, now our arc frame members insertion is finished. Now let's insert a pipe profile, which is to body between these arc beams. Let's select this profile. You can use smart points on the frame members. By the way, I have to choose the straight as an insertion method. Okay, the reason for inserting frame members, these frame members one by one, is if I click the first first frame member and the last frame member, the pipe profile frame member will be created as one. The frame member will be created as one frame member between these arc-shaped frame members. That's why I should insert one by one. And let's select these frame members and change the hinges. Let's select the pipe frame members, right-click the properties, and change the hinges from here. Okay, close. Now let's define braces between these columns. Oh, hang on. I want to assign steel beam. Let's assign steel beams between these columns. Let's change the section as pipe section. You can use the pipe section in the steel beams as frame members, like frame members. And you can change the end releases as well. Let's select M3 and let's support type as none. And let's define it. Okay, our pipe profile steel beams were created. Let's assign a brace between these columns. Let's select only one brace and click. Now let's add claddings above the purlins after the inserting braces. Claddings can be inserted above the purlins, or also you can insert claddings to the girts as well. Okay, now let's pass to the loading parts of our webinar. In the loading parts, let's click load case and combinations. For example, in the loading generator, you can define snow loads, rain loads, temperature loading, and wind loading as a horizontal load. Let's pick the snow loads and rain loads. Let's click the temperature loading. And as I mentioned before, you can assign wind loading. Also, you can assign seismic loading. You can assign negative way. And if you want to create a new load case, click load case and write labels and description. For example, LA, LE, and this load case is equipment loads. Don't forget to click include in story mass calculation. As you see, LE load case was appeared. LE load case was appeared right now. Okay. Now I want to assign full uniform area loads to the claddings. Let's look at the load cases and change the magnitude as 0.05 and assign the whole claddings like this. Let's click OK. Let's assign a full uniform load to these arc-shaped frame members. Let's change the magnitude. Now I want to copy the loads that I inserted to frame member, and I want to paste it to the other frame members. Let's select the control button, right click and paste loads. Now let's make the building analysis. Click the building analysis button. Okay, now it's finished. Now let's design the steel columns and steel beams only. And you can click the check all button. Okay, now you can also take the design reports, detailed design reports from the report tab. Now let's design the steel beams of our model. Let's click check all button. We have a lot of steel beams in our steel structure. Their number is higher than steel columns. Also you can take the detailed design reports from report tab. Okay, it's finished right now. For the detailing the steel members and prepare the drawings, we must import the building model into ProtaSteel. While the members are transferred to ProtaSteel, the internal forces calculated as a result of analysis are also transferred. ProtaSteel makes connection design with macros by using internal forces of the element of the members. We will not touch on this subject within the scope of the webinar, but you can access educational tutorial videos about ProtaSteel on our YouTube channel. Now let's pass to one of the other topics about this webinar, which is steel dome modeling. I created a model before for you. For inserting steel domes, click 2 points in the model. After that, the parametric dome wizard will welcome you. Now let's change the dome height to 500 cm. And let's add crown frames. Crown type can be segmented or single. You can change the crown radius and height. Also you can change the one of them. The other one is automatically changed. Longitudinal span counts can be arranged. You can change the type of the span counts. It can be single or segmented, the type of the longitudinal frames. Also you can use latitude frames as well. Or you can use support frames. These are very important properties, very important members for dome stability. You can change the brace fill type such as double, single or staggered. Let's select double. Also you can change the longitudinal fill type, one fill, one empty, one fill, two empty, two fill, one empty or more. Or you can select the custom option. So let's select only first and second. As you see, let's make the full. You can add Purlins frames as well, or you can add Purlin on latitudes. In the section part, you can change the sections as well as the other steel structures, or you can edit the end releases manually, the joints. Now, let's assign some loads to the steel dome, our steel dome. I want to assign full uniform area loads to the panels of the steel dome. Change the magnetized to 0.05 and let's assign a full uniform load to here, and I want to assign the trapezoidal load to the steel dome. You can take the detailed reports from here. You can look at the load types, load cases, directions, magnitudes, positions. All of them are here. You can change the report type as Microsoft Word file or PDF. Thank you for attending our ProtaStructure webinar today. I hope that it would be very useful for you. Also, this webinar record will be uploaded to our YouTube channel. Hope to see you in the next webinars.